Okay, so go ahead and start the recording. Again, this is week 7 chemistry. What we're going to be looking at in chemistry is not a very hard concept, believe it or not. It's just looking at dissolve rates, basically. It's not even that big of a deal. And when you see this, it's going to be a pretty quick lab because it's not that hard. I really don't know how to put that any other way, but it's not that hard. As soon as you see it, you're going to be like, why did we do this? This is stupid, is what you're going to tell me. Well, and some people loved it because it's, you know, good for them. But I looked at it again, I forgot this lab, and I was like, wow, that's what we're doing, huh? Cool. So I have my TA, she's printing out the stuff right now. We'll go ahead and get going. So talking about some factors that affect solutions. Now, first of all, what the heck is a solution? Now that's the question. Does anyone know off the top of their head what a solution is?
It's kind of like something that I think is dissolved into a form of a new thing.
Okay. He says something is dissolved into and it forms a new thing. That is 110% correct, except for some of the words that you should probably use.
You got it.
Okay. Do you know some of the words?
It's solute and I don't remember the other one. But
Okay. Very good. You have a solute and you have a solvent. Both a solute and a solvent make a solution. Basically, one of them destroys the other one and jacks a whole bunch of their molecules and separates them. Okay? Water is a universal solvent. But let's think of, you can think of other ones, but let's use water because you're used to it. Today, in the lab, we're going to use salt. What happens when you put salt into water? Does it stay there? Can you stare at it? You're like, look at my little salt. Oh my God. You get all happy that they're just sitting there?
no.
No. They go away. They become salt water. They go together. In that case, which one got dissolved? The salt. Okay, anything that gets dissolved is called the solutes. It's the weak. Okay, solutes are all weak. Don't be solutes in your life. Don't be weak. Now on the other side, the solvent is the one that kind of broke the other one down. Water is a solvent then, right? You agree? Together, they become a solution. They're different than both of them. They're chemically together. Now, if I was to take a bunch of salt, or not a bunch of salt, but a bunch of mud, little, like a thin mud, I'm talking like the silt, put it in my water bottle, shake it up, spin it around, and then just let it sit there, is it a solution? Why not?
It didn't dissolve.
It didn't dissolve. You could reseparate it, I think is what you're, yeah, very good. You could reseparate it. You just let it sit there, and eventually the heavier parts will fall to the bottom. You'll still see that nasty stuff at the top, but it's not part of it. It's just floating in there. It's based on density. It has nothing to do with being chemically the exact same. The only way to get rid of chemicals that are dissolved is usually through a process. Evaporation, like if you leave your salt water out, it's outside, you give it a few days, and it doesn't rain inside of it, you have your salt again. All the water's gone, you have your salt, and you can just get all giddy again, okay? Because I know how you guys get when you get your salt. You all giddy. All right, next.
I don't know how to do this. Sit in front.
Arrow. Now, a couple things when we talk about, and I'm going to talk a little bit about the lab today, as well as just in general. We're going to talk about the particle size. Now, so you're going to kind of make a prediction on your paper in front of you, just in general. You can write on the back. It's blank on the back of your lab sheet. Which particles do you think will dissolve the fastest? We're going to look at 3 different ones, and for the people at home, you're more than welcome to go to your lab kit, and you can pull out your sodium chloride. Now, 3 different ones came in your little lab sheet. Okay, we got the fine salt. It's the best looking salt. It's fine. No one on the fine salt, huh? Okay, so fine salt is basically the same salt that you get inside of like any restaurants or you put on your food. That's what we consider fine salt. Now, there's then coarse salt. Coarse salt basically looks identical to, I'm just pouring this on your paper just so you have to clean it up, just so you know. Then we have, no you can't write, you can clean it up.
Yeah.
Now we have the coarse salt. Coarse salt basically is kosher salt. Anyone ever know what kosher salt is? Kosher. Anyone here cook with kosher salt? Anyone have any idea what that is? No. It's the thicker, more. No, it's this one.
Yeah, I know.
People don't know it's this one. There you go. So it's throwing salt. It's good luck, right? Right shoulder. Okay. But yeah, that's just the coarse one. It's the exact same thing. It's just thicker. The secret, if you ever go to a really nice steak restaurant, been to a nice steak restaurant lately? Like nice. Like $50 a steak night. Okay. Once a year I have to go do that. It's one of these things I have to do. Because the steaks are different. They age in like months and stuff. They're really good. But the secret is they actually just sprinkle with kosher salt and pepper. That's all they do. That's it. Then they put in the broiler. Really off the subject, but just in case you want to make a good steak. All right, so the particle size matters. Now let's spin this back around. But you're going to write down what you think will happen. Example, which one will dissolve faster? Do you think the big, which I didn't show you that, but I will. Big salt. Big salt. These are saltwater tablets. These are what water softeners use to clean the stuff that actually cleans your water. Okay, so that's what this is. So we're going to make a prediction of what do we think will dissolve faster, slower, or whatnot. And you can put a little reason why if you'd like as well. All right, let's go next. Okay, another one too is do you think that stirring will make a difference? So if I want to maybe pour something in there or pour the salt in the water, if I stir it, what do you think will happen? Don't answer that question. It's pretty obvious, hopefully, but you still should probably answer that yourself. Will it happen? Will it be faster, slower, have no effect? That's things that you guys need to think about. Is will it occur with it? Temperature. Okay? Hot, cold. Does that matter? I don't know. Do you think it matters? We're going to talk about that. I'm going to heat up some water in one of these bad boys, and then we're going to put in there. I don't know if those are safe. We're going to try. Shane's going to put stuff in there, and hopefully it doesn't melt and destroy everything. Okay, that's what I do. Okay, but if not, we can just talk about it because it's really obvious. This is the most obvious lab that you'll take. All right, so is temperature affected? Okay, and this kind of talks about what we talked a little bit about the making of a solution. So separate a solute into two-dimensional components, expanding the solute. This is just if you want to start separating, overcoming intermolecular forces in the solvent, or in the solvent to make room for the solute. So it's expanding and contracting. We'll actually see that when I do a little, you guys won't online, but in class they will. There's a simulator that I have. Allow the solute and the solvent to interact to form a solution. So what it's trying to say is, if I have a little bit of salt and I pour it inside a whole bunch of water, is it a true solution? By definition, it is. You put a solvent in, or you put a solute into solvent, therefore solution. But no, you don't, because it really matters of how much actually mixes. Most of it's still water, and there's probably some that has mixed, but it's not a full mixture. That's important to know how many of each. All right? All right, so here are the steps in the process of actually, next. Good. Next. Keep forgetting that you're not. There you go. All right, so this is visually what you told me. You take a solute, I take a solvent. Okay, so in this case, oh, look at it, I get a right on this. Look at this, isn't that amazing? You guys love technology. Look at that. Can't see it on here, but I'm writing on here. Don't drop it in the screen, don't drop it in the screen, don't drop it. All right, so right here, you have your solvent, you have your solution. You start putting them together, and then you get an expansion of the solvent, and you get an expansion of the solute, and then they basically mix together into a solution. Sometimes it will actually rip apart certain things, and sometimes it just kind of mixes in perfectly, and they have a perfect harmony with each other. Sometimes. Next. Okay, so in the lab that we're going to do today, as well as you guys are going to do online, you're going to test each of the predictions, and we're going to look at each of those predictions here in class and see what are some of the things you had right and some of the things that you maybe misunderstood, and now you hopefully have a better understanding. Make sure you do be prepared to this idea of kinetic theory, and that'll make more sense when we actually get into the lab. And then make sure one thing too, next, is that everyone that does the lab, I want you to make sure that your writing is clear, and English would be good. All right, I'm not saying you have to do English. If you know another language and it's full, that's fine. I'll have just anyone else check it. But English should be the greatest because I can grade that. But English is one thing, and Another thing is answering with the word because as your first word. This happens, you just write because. Or putting I think, and the I is the lowercase I. Okay, grammar. Let's make sure we start upping our game on grammar. And make sure you, again, use some of your original predictions and answer those inside of your lab sheet. Okay, so the people on the internet, what I want you to do is your essential question that I would like you to answer. Going back to the beginning. I want you to focus on this particle size idea, and I want you to make a prediction of, do you believe that one will be faster than another? And if so, what are other things that you can think of that will also affect the dissolve rate? Okay, that's the big part, is it's how fast it dissolves. All right, so this is a quick one for you guys. We're going to finish it up in class here. We're going to get the lab done, and I recommend coming in person because, hey, y'all are going to get double the credit. Smart of you guys to show up, way smart.